Okay, so let's do a couple questions for review. Now this one has a lot of going on in it, but just break it down piece by piece. So do you understand that if you put the letters and the numbers in a different order, that would create a different passcode? So is the order important? Yes. So since the order is important, this is a permutation. Okay? Permutations, they can either be done using that little NPR key or they can be done using the blanks method. Okay? The only time you can use the NPR key is if your blanks are counting down by ones, which almost never happens. Okay? So once you decide it's a permutation, because the order of everything that, like the code 35F2 is different than F235, right? So the order matters. So the next step is how many blanks do you need to draw out? So how long does your passcode have to be? 5 to 7. So that means it's going to be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. Right? 5 to 7 characters. Okay, now we need to figure out how many characters we have. So it says the password can use any digits 0 to 9. So this right here is 10 possibilities. So 0 to 9 is not 9 possibilities, it's 10. Any letters of the alphabet. The password is case sensitive, so both lower and uppercase are allowed. How many lowercase letters do you have? How many uppercase letters do you have? So 26 and 26 means there's 52 letters possible because a capital A and a lowercase a count as different. Okay? So a password must be at least 5 characters, maximum 7, and each character can be used only once in the password. So that means no repeats. So right here, no repeats. Okay? So does it say any other restriction? Does it say it has to start with a letter? Does it say it has to finish with a number? No. So you've got 10 numbers and 52 letters to pick from. So you've got a total of 62 choices for every single blank. Well, for the first blank. You've got a choice of 62 choices for the first blank. Because it could be an uppercase letter, a lowercase letter, or a number. If you're not allowed to have repeats, how many choices for the next item in your code? Oops, I should have written this on the top here. Sorry, I don't know why I did that. What's the next number going to be? 61. 60, 59, 58. Right? No repeats. Okay? So 61, 60, 59, 58, 57. 61, 60, 59, 58, 57, 56. So you would on your calculator go times, 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 plus, times, 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 plus, times, times, times. Are you expecting a fairly large answer? Yes. Which is, and then the odd, so then in our next unit, the next unit will say, what is the probability of somebody guessing your password on one try? It would be 1 over that massive number. Yep. Yes. So if you did this with P's, you would have 62P5 plus 62P6 plus 62P7, which looks way prettier than that. Okay, so if this was a diploma exam question, okay, this is how the ABCD will probably be written. So that will be choice A. What do you think they'll do for choice B? Instead of putting plus signs, they'll put time signs. And then choice C and choice D will be the exact same, but with the letter C in instead of P. And that's what we're going to cover starting later, like later this week. Okay? So, oh, this one's a little high. Okay, flip the page. Okay, so Josh, yesterday we talked about repeats. So how do you deal with a word if there's repeated letters? And all you have to remember is if you've got what I call identical objects. So in other words, if you have the word Canada, so there's 3 A's in it, okay? What you do is you take the total number, factorial, and you divide it by each repeat factorial for as many repeats as you have. So the word that we did yesterday was mathematical. So mathematical is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 12 letters. So there's 12 factorial. But then you would divide it by the 2 M's, the 3 A's, and the 2 T's. And when you plug that into your calculator, you just got to make sure and put the brackets around the bottom. Okay, so that's what we learned yesterday. Okay, so it says, how many ways can the letters of the word, the letters of what? Okay. So is that, did it get hidden? Oh, it's just, oh, there it is. Oh my. Oh, it's way, okay, I see what I did. Hold on. Move you down. There she is. Okay. So how many ways can the letters of the word Canada be arranged? So again, you have to recognize that there are identical objects. Okay. If the first letter must be an N and the last letter must be a C. Okay, so when you have identical objects, what you want to do is just do the denominator. Just get that out of the way. So what are your identical objects? 3 A's. Okay, get that out of the way. Done. Now for the top, you're going to do the top just like you did in lesson 1 and lesson 2. Okay, so how many ways can the letters of the word Canada, so we're going to use all the letters. So there's 6 letters. The first letter must be an N, and the last letter must be a C. Okay, so how many N's are there in Canada? 1. How many C's are there in Canada? 1. So I've used the C and the N. How many letters do I have left to pick from? Well, because they're Scrabble tiles, we assume no repeats, because once you've used it, you can't use it again. Okay? When you're dealing with the rearrangements of the letters of a word, it's always no repeats, because the implication is always Scrabble tiles. Okay? So how many tiles do you have left to pick from? 4. So it goes 4, 3, 2, 1. Now, this is a perfectly good answer. Okay? What's going to happen on that diploma is one of 2 things. They'll either have the answer written as a number, so you would just punch that into your calculator and off you go, or they'll write the answer in a simplified form. Okay? Does 1 times anything affect an answer? No. So 1 times this and 1 times this technically has no effect on the answer whatsoever. How can I rewrite 4, 3, 2, 1? 4 factorial over 3 factorial. So I want you to think like this, and then understand that the answer may be written like this. Okay, if you don't understand what the heck they are doing here, but you know you can do this 100%, you're going to take this and plug it into your calculator, get an answer. You're going to take their A, B, C, Ds, plug each one in, only one of them will match your answer. And if none of them match, you know you've screwed it up. Okay? Okay, underneath this question, there's one more I want you to do. Sorry, I forgot to photocopy it. Okay, so here she is. So it says, determine the number of arrangements of the word sundresses if the arrangement cannot start with an S. So the number of arrangements of the word sundresses, the arrangement cannot start with an S. I'm just going to hide it here for half a second. I'll bring it right back. Um, okay. Okay. I don't know why that is shifted that way. There we go. Okay, so you have to first recognize that you have identical objects. So if you have identical objects, go straight to the denominator. Don't even worry about the numerator right now. Just do the denominator. Okay, how many identical objects do you have? 4 S's, and what else? 2 E's. You didn't see the E? Okay, so 4 S's and 2 E's. Okay, before we do anything else, do you see how the ABCD is just 4 numbers? If you can't figure out how, if you do it and you don't get any of their 4 numbers that you have, you are circling a random letter and you're moving on. Either that, you leave it, come back to it, see if you can figure out what the heck you've done. There's no working backwards from the answers to figure out how to do this. They are Hail Mary questions. You either get them or you don't. Okay? It's the only unit like that. All the other units, you have a way to kind of limit your choices or eliminate stuff or work backwards. So determine the number of arrangements. So number of arrangements. So this is a permutation. Okay? Are we using all the letters? Yeah, we're using all the letters. Right, so it's Sundresses. Okay, so we're using all the letters of the word sundresses. So the first blank cannot be an S. So how many Scrabble tiles are not S? 6 of them. So you've got 6 choices for that first blank. Do you have any other restrictions? No. So you've used one, so you've used, let's say, the letter U, because that's not an S. How many Scrabble tiles do you now have left? 10. So you're going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, nope. 1, 2, 3, 4, 5, 6, 7, 8. You got 9 left, Melissa. So 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? So if you wanted to make this a little easier on yourself to plug in, you would go 6 times 9 factorial over 4 factorial 2 factorial, and then make sure you put brackets around the top and brackets around the bottom. And if you do that, you should get out one of those answers. Okay, so if you need to take a break, go ahead and do that. Whoops. Whoops. Okay, so let's do one more review question, and then we're going to deep dive into the last type of permutation question that you can get. Okay, page 81, yeah. So it says answer the following either using fundamental counting principle or factorials, right? So we can do it either way. In how many ways can all the letters of the word oranges? So again, oranges is on Scrabble tiles. If there's no further restrictions. So you're going to use all the letters. So how many letters are there in oranges? 7. So if you wanted to, you could just go 7 blanks and go 7, 6, 5, 4, 3, 2, 1. Right? Because you got 7 choices for the first letter, then 6, then 5, then 4. So that is the same as saying 7 factorial. Okay. And what you missed, Josh, is another way to show this is there's a representation called NPR, P for permutation. So N is the number of objects that you have. So we have 7 objects. And R is the number of those objects that we are arranging. So we are arranging all 7 of them. So you would go 7p7. Where that factorial button is on your calculator, this is number 4. Where the same menu, this one's number 2. So if you punch this in on your calculator, so what you do is you hit the 7, you go to math, you go to probability, and you pick number 2, and then you just punch in the 7 again. That will give you out the same answer as if you go 7 times 6 times 5 times 4 times 3 times 2 times 1, which will be the same as factorial. So 7 number 4, 5040. Okay? And in this unit, it sometimes the answers give you pause. You're like, there's 5,000 ways of rearranging the letters of the word oranges. Yes, there are. Okay. What if the first letter must be an N? I did it again. So how many N's are there in the word oranges? 1. So you've used the letter N. You can't use it again. How many letters do you now have? How many Scrabble tiles do you now have left in front of you? 6. So this would just be 1 times 6 factorial. Or 1 times 6p6. Now what's 1 times anything? So you could just shorthand it to that. Yep. So the reason why I'm saying it this way is if they write the ABCD like this, I still need you to think of it like this. Because you're going to be wondering, going, what the heck? I have 7 Scrabble tiles. Why are they only using 6? But if you think about it like this and write it out like that, this makes way more sense. Does that make sense? I know I'm sound like a kind of broken record, but I need you to not get hung up on the way they've written the answers. I need you just to think about each question and do it and then match it up after the fact. Okay? Okay, so here's another scenario that we haven't done before. 3 girls, G1, G2, G3, and 4 boys, 1, 2, 3, 4, are to be arranged in a row for photographs. So again, they're arranged. So this is a permutation. In how many ways can this be done if there's no restrictions as to who stands where? So how many people are you arranging? 7. So it's 7, 6, 5, 4, 3, 2, 1. 7 choices for the first position, then 6, then 5, then 4, then 3, then 2, then 1. Or 7p7 or 7 factorial. You getting the gist of this? Okay, the more questions you do in this unit, the way easier this unit becomes. Okay. The photographer decides that he could take a better photograph if no 2 people of the same gender sit together. What does that mean? They have to alternate. So you've got more boys than girls. So that means it has to go right. Boy, girl, boy, girl, boy, girl, boy. 4 boys, 3 girls. Okay. Just give me a second here. Okay. How many boys do you have to pick from for the first position? 4. Then how many boys do you have to go in the next chair? Then how many boys? 2. Then 1 boy left. For the girls, how many choices do you have for the first girl's position? Then. So do you understand that you could just punch into your calculator 4 times 3 times 3 times 2 times 2 times 1 times 1? Does that make sense? Okay, look at the yellow. The yellow is 4, 3, 2, 1. So I can rewrite the yellow as 4 factorial. Look at the green, 3, 2, 1. How could I rewrite the green? And then you can multiply. These 2 things give you the exact same answer. Okay? There we go. That's the answer for number 2. Okay, so just my job is just to huck as many different questions at you as possible. I understand though that the diploma, so those questions that you just did on the quiz, did we do anything exactly like those? No, but it doesn't matter. If you understand the concept of the blanks and doing the restrictions and all that, I can huck whatever I want at you. Okay. Okay, 6 actors and 8 actresses. Oh, I don't like this question. We're not going to do that one. It's a stupid question. Okay, next one. Okay. Andrew was asked to determine the number of arrangements of the letters of the word brains in which the vowels are together. Okay, so vowels, remember, are A and I. So A and I have to be kept together in all the arrangements. So he wrote, since the vowels must be kept together, I'll treat A and I as one element. Or in other words, he'll pretend that A and I are on the same Scrabble tile. So what he's essentially saying is that he's got a Scrabble tile with a B, an R, the AI are one Scrabble tile because they have to be kept together, the N, and the S. Okay? This means I now have 5 Scrabble tiles. Is he correct? 1, 2, 3, 4, 5. Yep. Instead of 6, right? Because he stuck the A and the I together. The 5 elements are that. So how can I arrange them? 5, 4, 3, 2, 1. So 5 factorial ways. Okay? There's a problem. He's close. He's just not quite. Is Andrew correct in saying that the A and I should be combined as one element? Yes, because they have to be kept together. But it said that they have to be kept together. It could be IA, not AI. So what you have to do is think of it as, think of the AI together, and then you've got the B, the R, the N, the S. So how many tiles do you have? 5. And there's 5, 4, 3, 2, 1 ways of arranging 5 tiles, right? And then you have to multiply that by how many ways could you have AI? Well, you could have AI or IA. So you have to times it by 2. So the answer is 240, not 120. So he was almost there. Okay. So I refer to these questions as together questions. Okay. Because you're literally going to stick things together. And now we could stick people together. We could stick letters together. We could stick anything we want to together. We could stick fruit together. Like if I gave you a basket of a bunch of fruit and I say, okay, you must eat the kiwis at the same time. You got to eat all 3 kiwis together. Yeah. Okay. So here is what I need you to know. This formula, just like the repeats formula, is not on the formula sheet. You simply have to know it. So I just handed this out to you before we started. Okay. I need you to think of when you see the words together, I need you to literally think duct tape. You're going to stick these items together. In other words, you're going to create a Scrabble tile where those elements are stuck together. If you do that, the formula to solve them will always be this. You take the number of items that you stuck together and you factorialed it. Now, what is the value of 2 factorial? 2 times 1. What's 2 times 1? 2. So on this one, does it matter that I have the factorial sign there? No. But if I had 3 items stuck together, is timesing by 3 the same as timesing by 3 factorial? No, those are 2 different numbers. So whatever number you've got here, make sure that you factorial it, not just times it by 3. Times it by 3 factorial if you stuck 3 things together. Here's the catch. This is what everybody gets wrong. You times that by the number of new items. So I originally had 6 Scrabble tiles for brains. When I stuck the A and I together, my new total is 5 factorial, not 6. It is this word right here, the new total. Okay? So, technically on the diploma, I did not see any of these not together questions on the diploma, but they are technically fair game. Okay? This is more a 30-1 concept, whereas this is both 30-1 and 30-2. This is a memorization game. Here's what I want you to visualize here for the not together questions. Let's say I take 1, 2, 3, 4, 5, I take all 7 of you. And I line you up in a photo. So I've got all these different ways of lining up 7 people in a photo, right? 7 factorial. Yes? 7, 6, 5, 4, 3, 2, 1. Do you understand that some of those groups, in some of those groups, Abby and Melissa will be together? Are they going to be together in all the photos? No. But are they going to be together in some of the photos? Yes. So do you therefore understand that everything outside of that is the pictures where Abby and Melissa are not together? Right? This is where they are not together. So for a not together question, what you do is you just do the no restrictions. You've got 7 people. 7, 6, 5, 4, 3, 2, 1. And you minus it the opposite. Well, what's the opposite of not together? Together. How do you do together questions? Right there. So in 30-1, this is a guaranteed question. Because in 30-1, they can force you to do a together question by making you do a not together question. They can force you to know both formulas. On the diploma, I only saw this one. I did not see this one. But we're going to practice both because they are in your workbook. Okay? This is a memorization. This formula is not on your formula sheet. This is a need to know. Okay? Okay, so if you look at example number 5. So it says find the number of permutations of the letters in the word kitchen. Okay, so imagine the word kitchen, each on its own little Scrabbly tiles. So how many Scrabble tiles do you have? 1, 2, 3, 4, 5, 6, 7 tiles. Okay. The letters K, C, and N must be together, and they must be in the order K, C, and N. So we're going to put K, C, and N together on one tile, and we're going to keep them in that order. So let's write out our tiles. I is still on its own tile, T is on its own tile, H is on its own tile, and E is on its own tile. So just make sure you've got all your letters. K-I-T-C-H-E-N. Kitchen. Okay? So what is my new total of Scrabble tiles? 5. So I'm going to go 5 factorial times by. Now, am I allowed to rearrange those items that I stuck together? No. So I'm going to times it by 1 factorial because there's only one way I'm allowed to have that, and that is a K, a C, and then the N. Now look at this one. K, C, and N must be together, but not in that order necessarily. So I'm just going to write it out again. Do we still have 5 tiles? Yes. But now These can be in any order that my little heart desires. So I stuck 3 things together. So I times it by 3 factorial. So here's a twist on this. Let's go back to part A. I'm going to read the question worded another way, and I want to see if you understand it means the same thing. So the workbook says the letters K, C, and N must be together in the order K, C, and N. The diploma might say the letters K, C, and N must be together and must be in alphabetical order. If it's alphabetical order, how many ways are there of doing alphabetical order? One way. It has to be the C, then the K, then the N. So alphabetical order and must be in this order, it's the same question. Okay, but the key here, the word together. Just like yesterday, the key was identical objects. Okay, so I'm not going to bother plugging in on your calculator. I'm assuming you can do that just fine. Okay, Frank, George, Hannah, Iris, Jacob, and Kim have playoff tickets for a hockey game in adjacent seats A3 to A8. Adjacent means side by side. Okay. In how many different ways could they sit together? So there's no restrictions. So how many people are there? 6. So it's just going to be 6, 5, 4, 3, 2, 1. So 6 choices for A3, 5 choices for A4, and so on and so forth. Or if you prefer, 6 people, you're arranging all of them, 6p6. Or 6, 5, 4, 3, 2, 1. Good? Splendid. George and Hannah are dating. Aw. And how many of the arrangements in A would they be sitting together? So we want to, now we're going to keep this G rated. We're going to duct tape George and Hannah together. Okay? Keep it G rated here. So George and Hannah are going to go, they're going to sit side by side. They're going to move as a singular object. So you had 6 people, but now you have George, Hannah, and then your other 1, 2, 3, you have 4 other people, right? Because there's 6 people total. So what is your new total? 5. Now, does it say that George has to be on Hannah's left? No. So could it go George, Hannah, or Hannah, George? Yes. So you times it by 2 factorial. Together questions aren't hard. It's just remembering the stupid formula. Okay? Just before the game, George and Hannah have a little squabble in Lover's Lane and decide not to sit together. So this is a not together question. So all you do is you go, okay, what are all the combinations possible? What are all the different arrangements? Well, there was 6 people. So 6, 5, 4, 3, 2, 1. Because remember, that's your total bucket. And then within that bucket, some of them, George and Hannah, were sitting together. Things were happy. So we have to minus off George and Hannah being together. So that is what we did up here. Because if you think about it like this, here's your bucket of your 6 people. And here's all the different seating arrangements they could have. In some of those seating arrangements, George and Hannah are together. But in all the rest, they're not. So if you go total number minus the ones where they are, you'll get all the other arrangements where they're not. Make sense? Okay. So here's the questions that are fair game. Have you caught up to me? You're good? Okay. So anything on page 83 is fair game. Okay. So some of them are together questions, some of them are just plain old fill in the blanks. It's just kind of a hodgepodge of everything that we've been talking about. Now, if your time is limited, go straight to question number 7, okay? Because 7 all the way to 13, that's your multiple choice numeric response. So those are the ones that are like the diploma. Okay, so do those 6 questions. And then if you want to have any other practice, you can do that. Okay.